With chem blocks I learn easily when I study chemistry. Chemistry for you and me. Chem blocks does the trick for me.
In this segment, we'll discuss a special class of ionic compounds reactions, double exchange reactions, or metathesis reactions. We'll focus on double exchange reactions in which a precipitate, that is, an insoluble solid, is formed. Reactions in which two of the ions present in solution combine in an insoluble product, or precipitate, are called metathesis reactions with formations of precipitate. Other types of metathesis reactions include gas evolution or formation of a non-dissociated compound. A general pattern for metathesis reactions with precipitate formation is AB aqueous reacts with CD aqueous to form AD solid and CB aqueous, in which a solution of compound AB reacts with a solution of another compound CD to result in at least one insoluble product, in this case AD. We see that the cation, A positive, of the first compound binds to the anion, D negative, of the second compound. One can tell which of the products is insoluble based on tabulated data or other solubility guidelines. A typical metathesis reaction is that of potassium iodide with lead-2 nitrate. When the lead-2 nitrate solution is added dropwise to the potassium iodide solution, a beautiful yellow precipitate forms. The chemical equation for this process is the one in which lead-2 nitrate reacts with potassium iodide to result in lead-2 iodide precipitate and a solution of potassium nitrate. We notice that the equation is balanced. This equation is known as the molecular equation. This metathesis reaction can be better understood and analyzed using the chem block system. For starters, we use the ion chart to build the models for the two reactants using ChemBlocks blocks. The appropriate chemical identity has been assigned to all the blocks involved. Through dissolution, as discussed in another segment in this series, the ions of soluble substances separate completely. Thus, the two solutions contain the lead-2 ions and the nitrate ions, and the potassium ions and the iodide ions, respectively. When the two solutions are mixed, the metathesis reaction occurs and the yellow lead-2 iodide precipitate is formed. The equation for this process reflects the ions involved and the insoluble product. This equation is the full ionic equation. By comparing the situation before and after the reaction, it must be noted that some ions remain in the same form before and after reaction. In our example, those are the potassium ions and the nitrate ions, circled in red. The full ionic equation, written with those ions in red, is 1 lead-2 ion and 2 nitrate ions and 2 potassium ions and 2 iodide ions result in solid lead-2 iodide and 2 potassium ions and 2 nitrate ions. Those ions in red are called spectator ions because they do not take part in the precipitate formation. We may disregard the spectator ions, keeping only the ions that participate in the formation of the precipitate. In this case, the equation becomes much simpler, and it reflects the fact that precipitation would occur if the original compounds contained other counter ions. For example, if we started the process with sodium iodide instead of potassium iodide, or with lead-2 acetate instead of lead-2 nitrate. Net ionic equations show only the ions involved in the formation of the precipitate. We are now familiar with metathesis reactions, in which two ionic compounds exchange ions and one of the products is insoluble. One compound's anion binds to the second compound's cation, and vice versa. We also became familiar with molecular equations that show the ionic compounds involved in the metathesis reaction, and with full ionic equations that show all of the ions involved in the metathesis reaction. Finally, we also became familiar with the concept of spectator ions, ions not involved in the formation of the precipitate, and with the concept of net ionic equations that show only the ions involved in the formation of the precipitate. Before we go, here are two important observations. Number one, when dealing with metathesis reactions, chemical equations must be balanced. Also, number two, the precipitates form irrespective of the identity of the spectator ions. In our example, the same precipitate, lead-2 iodide, would have formed if we used sodium iodide instead of potassium iodide, or if we used lead-2 acetate instead of lead-2 nitrate.
With Chemblocks I learn easily when I study chemistry, chemistry for you and me. Chemblocks does the trick for me.